Okay, so now we're going to work on the homework from section 1.3. That's on page 37, and I've listed all the problems out. I want you to do the same. Number 1 is just a definition question. So you recall that on an interval, if f of x1 is greater than f of x2, then that is decreasing. Number 3, I'm a visual person, so they give me 2 points, and even though, so the question is, what is the domain of f? So if they were asking me if it was increasing or decreasing, I probably would do a sketch of those points, but since they're just asking me the domain, that is, and it is a line, they tell us, so from 1 to 4, that's the interval notation of the domain. Number 7, we are given a picture of a graph, and number 7 is an upside down parabola with a maximum at y equals 1, and it is centered on the y-axis. So the domain for a parabola is going to be all reals, so I would simply notate that like this, negative infinity to positive infinity. And then the range is the one you have to watch out for, because that parabola has a maxima at y equals 1, so the highest that it ever will get is 1, but the lowest it does go down to negative infinity. So this is the way we would write that range. Number 8 is going to be a similar type problem, except our graph looks a little different. We've got one inflection, it's probably a cubic graph. So we've got so we're crossing here. Okay, you can tell what these are just by looking at them, but like I said, I'm a visual person, so I do like to sketch things. So my domain, as I look across my graph, it appears that there's no value of x that is not that does not have a point on the function. So that's going to be all reals. My range, so I do have a relative max and min, but because I'm going on forever in the negative and the positive direction, then my domain is also all real numbers. Looking back at the directions for this section, I was also supposed to tell what f of 0 is. So at 0, my function here in number 7 is positive 1. Here at 0, I guess that depends how well did I sketch my graph. Looks like it's crossing at 2, so f of 0 equals 2 on this one. Number 13, you have to use a graphing utility to graph the function and then estimate the domain and range. So f of x is the square root of x minus 1. So the graphing utility that I have handy today is a TI calculator, and that's good that my function is already solved for y, as it were. So let me do the square root of x minus 1, and let's just take a look at what it looks like here. So I'm not getting anything to graph, so I'm going to do some troubleshooting and I'll be right back. Okay, so that was interesting. my issue, whenever I can't get my graph to graph, I always want to check the window. And this is my son's calculator, so he had all numbers in the millions here, so his window was really huge. So that graph was graphing, it was just microscopically tiny. So I went back and changed everything in the window to the standard window, an x minimum and of -10 and 10, and then the y's the same. So now when I look at the graph, I can see that my graph starts off at 1, 0, and then it increases as x increases. So the question is asking for an estimate of the domain and range. So my domain, one way I can look at that is I can see that everything less than an x value of 1 gives me an error. So my domain must start at 1, and then it increases forever. So I'm going to go up to infinity, and then my range values, when I look at the graph, my graph does not extend below the x-axis, so the most highest x or y value that I've got is a 0, but then I am increasing pretty slowly, but I am increasing. There doesn't appear to be an end to this graph, so infinity is the range. So I'm asked to find the domain and range algebraically. So that's simply saying look at the function and tell what rules are there for your x value here. And I would get an error. I cannot take the square root of a negative number. So I need to know, when is x minus 1? When does that become a negative number? So that becomes a negative number whenever the whole thing is equal to 0. So to solve it algebraically, I can see that when x is 1, that's when my function equals 0. So when it dips to be less than 1, that's when the whole thing ends up being less than 0. So this would tell you the values where your x is not part of the domain. For number 17, let's take a look. We've got a picture of a graph in number 17, and that's an absolute value function. So, and we're given that the function, here we go, is the absolute value of x minus 1 minus 2. So I know, and I'm going to, in the next section we're shifting and transforming functions, but I can tell by the graph that my vertex, or the inflection point, is at 1, -2. So that graph at 1, -2 is where that thing stops and changes directions. So looks like all the way across on my x's, my domain is all reals. But my range, you can see here, -2 is the lowest that it will ever go, and then it goes up to infinity from there. So how would I solve that algebraically? I'm not really sure what they mean by that. Like I said, I'm a visual person, so let me think about that. Okay, so what I've done is I have committed the same sin that students have been doing for years and years and years. I jumped right in and started solving the problem without reading the directions. So it turns out I have got to do all sorts of things with this graph. Determine the domain is just part A, and the range is part B. But for part C, I need to find where is f of x equals 0. So I'm going to substitute a 0 in there. And then I'm going to add 2 to both sides. So now I've got positive 2 equals the absolute value of x minus 1. And then we have a certain methodology that we have to use for solving absolute value equations. We have to split the equation in half. So I need to see when does x minus 1 equal 2 and when does x minus 1 equal negative 2. So I can add 1, kind of simultaneously solve these. X equals 3 and x equals negative 2 plus 1 is negative 1. So that's going to tell me, you know, over here at negative 1 and up here at 3 is where that thing is going to equal 0. So that's the answer to letter C. D, what are the values of x from part C referred to graphically? Okay, so I've already answered that on my graph. And that's where it crosses the x-axis, so I would call that x-intercepts. Choice E, find f of 0 if possible. So let's substitute okay, absolute value of negative 1 is 1 minus 2. So f of 0 is equal to negative 1, and so we should be able to look at our graph. Of course, my graph is not perfect. In the book, this thing crosses on the y-axis at negative 1. So I assume that's what they're going to ask me in F. What is the value from that part referred to algebraically? So that is the y-intercept. What is the value of f at x equals 1? So in my picture, 1, negative 2, f of 1 equals negative 2, or I could say like 1, negative 2. What is the value of f at x equals negative 1? So when I look at my picture, the point negative 1, 0 is on the graph, so I could state it that way, or I could say f of negative 1 equals 0. The coordinates, so now I'm looking at I. The coordinates of the point on the graph of f at which x equals negative 3 can be labeled, so negative 3 comma f of negative 3, or negative 3 comma what? So I think what they're asking is, of course their picture doesn't show what the graph, where the graph is at negative 3. I would have to substitute negative 3 into the function in order to find that out. So let me go ahead and do that. I'm going to just substitute out to the side here. So f of negative 3 would be negative 3 minus 1 minus 2. So that's negative 4, absolute value of negative 4 minus 2, which is 4 minus 2. So that equals positive 2. So that is my answer for I. Alright, number 19 is a yes or no question. You just have to look at the picture of the graph and do the vertical line test. So yes, that one very clearly is a function. How can you use a graphing utility? Well, I hope you know how to plug that into your calculator. Number 25. So I'm going to read the directions And they are nice enough to give me a picture, so I need to determine the open intervals on which the function is increasing, decreasing, or constant. So for this one, I'm going to just write increasing, decreasing, constant, and then I'm going to visually inspect the picture, and I can see that from left to right I am increasing all the way from negative infinity until I get to 0. Then that thing turns around and it switches from increasing to decreasing. So then I'm decreasing between 0 and, what is that, 2? And then I'm never constant, but once I get to 2, that thing increases, it turns around from decreasing to increasing again. So then I will go from 2 to infinity to be increasing. So I'm just going to put a comma between those. I'm not going to do a union or a of the sets or anything for right now. Let's take a look at our next problems. We have 3 odds in a row, 27, 29, and 31. So we're going to graph the function on our calculator, and we're going to determine increasing, decreasing, constant. So when we graph, in number 27, we graph f of x equals 3. So I'm expecting that to be a horizontal line, and it is. So I could tell that that's neither increasing nor decreasing. It's actually constant from negative infinity to infinity. Number 29, I'm going to graph x to the 2/3 power. So x raised to the 2/3. Always put fractions in parentheses in this calculator. And let's see if we get something. Okay, so it looks like on the left side, so we're never constant, so I'm going to make a notation here. I'm looking for some increasing domain values and some decreasing. So we start out at negative infinity, and then when we get to 0, we stop decreasing and we start increasing. And number 31, so I'm going to take x times the square root of x plus 3. Okay, so it looks like, let me look at my table just to be sure, it looks like when x is negative 3, we start our y values at 0. And we decrease, but then we're back up to 0 again at 0. So let me check the graph again. But at some point between negative 3 and 0, we turn around and start increasing again. So let's see. Algebraically, that function was x times x plus 3. So where do you think that things turn around? Well, I see we came down to negative 2, and then we actually started going back up again between negative 2 and negative 1. So why don't we just make that the cutoff? So we decreased from negative 3 to negative 2, and then we increased from negative 2 for the rest of the time that function exists. Number 45. The directions, well, the title of that is relative minima and maxima. So we're going to graph that function and take a look. In number 45, we have f of x equals 3x squared minus 6x plus 1. Now, here's where graphing is great and a graphing calculator is awesome. But if you have any knowledge that you can draw on from Algebra 2, or even algebra, that is going to be helpful to you in this course. So I'm looking at my graph. I was predicting that it would be a parabola because it is a quadratic, and we kind of do those over and over and over again in Algebra 1 and Algebra 2 until we're so sick of parabolas. So I can see it looks like my inflection point is, or my vertex happens at x equals 1, but just drawing on some previous knowledge, I know that I will be able to find the x value of my vertex if I can remember about negative b over 2a. So b being my middle term, negative 6 is positive 6, 2 times 3 is 6, so I'm expecting for that vertex to happen at x equals 1. So it's going to be a relative minimum, and then to approximate it, I can just take 1 and plug it in, or I can go into my table actually, and I can see where is that function when x equals 1, and I see that at 1 that function is at negative 2. So I'll say I've got a relative minimum at 1, negative 2. And that is all they ask for. So now let me look on number 47. This is called Library of Parent Functions. So that tells me I can look back at my greatest integer function. So I am thinking that, knowing what I know about transforming functions, I am expecting this to be 2 units up, but let's try a few for practice. So say if I have f of 0.5. Well, I would substitute that in, and I would do the greatest integer of 0.5, and then add 2 to it. So the greatest integer of 0.5 is 0 plus 2. So at 0.5, I'm going to be right here at 2. So that tells me I'm right. My entire graph is just shifted up 1. So there's 1. And at 2, so from 1 I'm going to add 2 to that, and I get 3. And so that goes on forever. Interesting. And I don't have to find domain or range or any of that stuff. Number 59. I want to sketch the graph of the piecewise function, so let me get some more room here. And it doesn't say to use the graphing utility, excuse me, so I am going to just use some good old-fashioned graph paper. You guys could just sketch a coordinate plane, or I happen to have these graph paper post-its, so might as well use them. So let me write down the function. I've got f of x equals my domain is split into 3 pieces, so I've got x plus 3 when x is between x is less than or equal to 0. I've got f of x equals 3 when x is between 0 and 2. And then f of x equals 2x minus 1 when x is greater than 2. Okay, so let me draw my coordinate plane here. So I'm looking, these are my neighborhoods. So x is less than 0. So that's everything over here to the left of the y-axis. And that's going to be x plus 3, and that's a closed circle. So I go to x equals 3, and then the slope is 1 over 1. So that graph is going to be a positively sloped line. Use my straight edge. Alright, now between 0 and 2, so my neighborhood there, it ends at 2, so it's on the y-axis, and then it ends at 2, and that function y equals 3, or f of x equals 3, and then I've got, so I had an open circle there, but it was right on top of this closed circle, and here I have a closed circle. My last one, x is greater than 2, so everything to the right of 2, I'm going to have the graph 2x minus 1. So I could go to -1 and kind of sketch my graph up until I get to that domain, or I could just go ahead and say, make a little table of values and say, what will that function be when x is 2? 2 times 2 minus 1, that's 3. So I'm going to be starting right there with a slope of positive 2. So rise 2 and run 1. And I could do my slope of 2 for the rest of my domain until I'm off the page. And number 61 is going to be very similar. Let me get a new piece of paper here. That up. So number 61, let me write out my function. I've got f of x equals, and I've got it split into 2 neighborhoods. 2x plus 1, x is less than or equal to -1, x squared minus 2 for x is greater than -1. So I'll sketch my coordinate plane. And my division of my neighborhoods is over here at x equals -1. And on the right, no, I take that back. On the left side, x is less than or equal to, so that's going to be a closed circle. I've got this 2x plus 1. So when x is -1, 2 times -1 is -2, plus 1 is -1. So at -1, -1, that's where my line is, and then my slope is positive 2. So I'm going to sketch that in. Then on the other side of that, I've got a different sort of shape. I know from Algebra 2 and Algebra 1 that this is going to be a parabola. At -1, I substitute that in. -1 squared is 1 minus 2. I'm still getting -1, -1. And this is a standard opening parabola. Just shifted down 2 units. So that's going to look like that. Alright, next we have number 83. And for this one, I've got a nice big fat set of directions, so I'm going to make sure to see what is expected. For number 83, f of x equals x times 1 minus x squared. And I've got to determine algebraically if the function is even, odd, or neither. And then I want to check graphically by using my calculator, and then I want to look at the table feature to compare f of x and f of negative x. So, starting out algebraically, I can plug in f of negative x, and I get negative x. And after I simplify, I get negative x times 1 minus x squared. Because negative x times negative x. It's just x squared. Okay, so now I'm analyzing that, and I want to be able to tell, is f of x, negative x equal to f of x, in which case it's even. Is f of negative x equal to negative f of x, which means it's odd. And so what I see here is that this is equal to negative f of x. So I'm going to say this is odd. That's my prediction algebraically. Now I want to graph it, and let's clear that. So we have x times square root of 1 minus x squared. Okay, that is super small right there on the axis. You can't even see it. Let me zoom in and see if that's any better. Okay, the lighting in there. You can see the reflection of my lamp. But you can see that it is symmetrical about the origin. So I think I was right in saying that it was odd, but now let's take a look at the table. And it looks like f of negative x is equal to f of x. Alright, let's try another one of those, number 85. And let's see our function here, g of s equals 4s to the 2/3. Oh boy. Alright, so let's do a g of negative s. So that is 4 times negative s to the 2/3. So what is negative 1? So you know when we have a power to a power, you can say, okay, that's negative 1 times s, so negative 1 to the 2/3 power, and then s to the 2/3 power. So off the top of my head, I am not sure what negative 1 to the 2/3 power is. So let's quit this. And let's see if we could use our calculator to see if that's even a defined power. Okay, so negative 1 to the 2/3, I think it's negative 1, so it's negative 1 squared, which is 1. Cube root of that is 1. Okay, so since this is equal to 1, that's still the same. So it looks to me like when we plug in a negative, we end up back with our original function. And that tells me that my function is even. So now I want to go in and program that into the calculator and see how that works out. So I'm going to do 4x raised to the 2/3 power. Let's see what that graph looks like. Alright, it looks very symmetrical about the y-axis. So, looks even to me. Now let's take a look at the table. And so we get at -1 and 1, we're both at 4. At 2 and -2, we're at 6.3496. And I have a feeling if I kept going, I would see definite symmetry on both sides of the y-axis there. Okay. So we're almost to the home stretch. Let's look at problem 105. Let's see. Number 105 says, does the graph in exercise 20 represent x as a function of y? So let me go back and look at number 20. So number 20 is one of those sideways parabolas. And if you've ever studied conic sections, you know that if I add y squared to both sides, so if f of x is y as a function of x, is this x as a function of y? So my immediate reaction is, well, that's not a function, so I wouldn't really call it that. But what I'm seeing here is that to determine if x is a function of y, you're going to use something called the horizontal line test. So it's x as a function of y. So we're just going to call this a learning homework problem and say, oh, very interesting, there is such a thing as a horizontal line test, and it's only used when we want to know if x is a function of y. Everything else that we've done so far with the vertical line test, that's telling if y is a function of x. So last one, number 109. Let f be an even function. Determine whether g is even, odd, or neither. Okay, so here's our assumption. F is even. So I'm going to go one further. I'm going to say f of negative x equals x, f of x. Okay, because that's the definition of even. So now they want to know, is g of x equal to negative f of x? And I would say no, because that's the definition of an odd function. So really, I'm just looking for one that kind of matches my definition here. So if g of x is equal to f of negative x, which is equal to f of x, then I would say, oh, okay, these are not yes or no questions. Hello. So we said in A that that was going to be alright, I'm going to ask you to rewind and start over. Okay, so f of x is even. So let me start and let me just picture f of x as a parabola. As the parent function, f of x equals x squared. That's the most basic even function there is. So for letter A, they're telling us g of x is equal to negative f of x. So for letter A, g of x would simply be negative f of x. And so is it even or odd? It's still even. Here, g of x is equal to f of negative x, and f of negative x is equal to f of x. So that would still be even because it would be the same function. And letter C, g of x equals f of x minus 2. So from what we know about transformation of functions, this would just go down 2. So that would be what g of x is, and it's still even. And choice D, we've got g of x equals negative f of x minus 2. So I'm not sure if they're expecting you to remember. See, transformation of functions is in the next unit, but you have covered this in Algebra 2. So x minus 2 inside the parentheses, that's moving that whole function 2 units to the right. And then by making it negative, they're flipping it. Okay, so right here is g of x, and that is flipped over and shifted to the right. It's not symmetric around the y-axis or the origin anymore, so that would be neither. And that concludes homework for section 1-3.